right.
So yeah, I guess, do you want an introduction?
Sure.
Okay. Well, it is my great pleasure to introduce to you guys our last Friday community talk. And today we're going to be hearing Dmitry speak. Dmitry Khan, he is, well, actually, what I've known of him is that he teaches search at University of Helsinki, and right now he is very much into vector search. And also by hearsay, I heard that he runs a podcast and he asks very interesting questions on a podcast. And so all you guys should go listen to his podcast and read his blogs. And so I think he has prepared for us a couple of things on vector search that he'll talk about.
Yeah, thanks, Judy. Really appreciate it. So I'll share, I'll start with slides, but my purpose here is to really make it a little bit more interactive and sort of test some of the neural search systems together. But let's start with the slides. And so this is kind of the same, almost the same slide deck I presented at the University of Helsinki. And then I also had a public presentation with DeepSet at the Open NLP meetup in January. So just really quickly about me. I have a PhD in natural language processing, or like rather mathematics, but the topic that I worked on was machine translation back in the days, in pre-deep learning era. And I'm currently with Silo AI. It's a Nordic lab, shipping AI talent to various clients, big and small, in different like verticals, NLP, computer vision, automatic speech recognition, you name it. I've been developing search engines for like past 16 years, both academically and industrially, from startups to multinational technology giants. So basically building like web scale search engines as well. Yeah, and I think during COVID, I didn't have much to do in my kind of spare time that was left after I didn't have to commute anymore. So I started researching vector search space, and later launched a vector podcast. And I've been also blogging about my findings on Medium, and so you can find it there, and also some source code on GitHub. So this is kind of like really a quick scope of like that what I did. We don't need to repeat all of these steps today, but I will definitely focus a bit more on motivation for neural search, and then what it is in a nutshell, if you want to get practical, and also demos. And so this is something, and if you feel like you want to chime in or share in the chat, like this is the question that I ask to the students, like what do you expect of a good search engine sort of experience? And this is what we collaboratively achieved, that they actually value privacy. For some of them, privacy is important, and that's why they use DuckDuckGo, for instance. But if the query is very specific, then they go to Google, because Google usually returns a more like relevant result. Another thing was that they would love to formulate queries in a more natural, intuitive way, rather than use like keywords. That's what I think Google and Yandex and other search engines taught us over the years. Oops, just a sec. Another thing is that, did you mean functionality might be super annoying sometimes? So like it tries to overly correct you when you don't want to be corrected, and you need to like click again and say, yes, that's exactly what I mean. And so UX matters a lot. And another thing is discovery, especially for students, probably like when they look for material, but also for some of us, like when search kind of blends with recommenders. And I'm curious, like if you would like to add anything into this list, like what do you think a search engine, what makes a search engine a good search engine, or maybe bad search engine? What you have seen beyond like Google and other search engines, but like whatever you're using, feel free to share in the chat, and maybe we can also like, or if you would like to speak up, let me know. Okay. So I guess maybe I'll start with the motivation for neural search, and also like feel free to add your thoughts in if you have spent some time figuring this out. But this is kind of like a new trend in the search engine space and also recommendation space. So if we start with inverted index, so basically what we built as part of this course, you know, using kind of BM25 ranker or something, we have, oops, I keep flipping the slide, sorry. So we have like, if we represent each document as an enumeration of terms that it has, so it will have a few ones, but most of them will be zeros, especially like if your term dictionary is like billions of terms. What this approach kind of lacks is that it's called bag of words representation, right? What it lacks is that, for instance, it doesn't have semantic context. It doesn't capture semantic context of words. So for instance, if it's capital as the main city of a country, or is it some kind of monetary value evaluation? Another thing is that it doesn't respect the word order. And I have to put an asterisk here. Sometimes it does if you actually use a specific operator within OpenSearch or Elasticsearch or Solr, but in general it doesn't. So for instance, if I say visa from Finland to Canada or visa from Canada to Finland, for inverted index, all of these, both of these queries are kind of the same almost, right? And so it doesn't figure out what exactly is it that I'm searching for. And feel free to bring more examples where you think this could be true, but another motivation for neural search is that if your data is not text, so if it's like images, audio, video, or any other object that you would like to encode and represent in search, so you can't really use inverted index for that. And also, can you find images with textual queries? So your users probably will still continue using you know, keywords or sentences to find your objects. Look, can you actually cross that boundary? So at this point, it becomes multimodal. So a few slides that I took from yesterday's Niels Reimer's presentation. I believe some of our students have been present there, and I highly recommend you to watch this video. And he basically explains what is all hype happening here. So if you see, we've had an interview with Ingersoll from the TREC. In the past, like roughly 20 years, there had been like a strong baseline system, search engine system, that was really outperformed. And even things like neural search, like blue dots, neural models like didn't perform well enough until sometime in 2018, when the BERT model was released. We started to see the new models like transformer based, and all of a sudden they started outperforming the baseline search on NDCG you know, scale. So there's some question. Okay, it's just somebody's sharing the YouTube video. Thank you. So in a nutshell, what is vector search or neural search? They're being used interchangeably. So it's a way to represent and search your objects. And this is the word that I'm using intentionally here, that it could be songs, images, not only documents. And you represent and search these objects in a geometric space. And so usually these spaces of high dimension, and also the vectors are not sparse, they are dense. So I've shown in the previous slides, it's like a sparse vector, you know, few ones and many zeros. But in a dense representation, you will have, you know, you will rarely have any zeros at all. And this screenshot I took from a search engine called Weaviate. It's a neural search engine, and here it kind of like oversimplifies the geometric space to like 3 dimensions. So here you have newspaper, magazine, an article, semantically related. And so they also will probably, maybe I should switch off the Slack, it's a little bit annoying. Sorry. So here, you know, these concepts are semantically related, and they are also close to each other in the geometric space. And the same for apple and banana as being fruit. But if Apple was a company, then it would be somewhere else in the space. Hope this makes sense. All right. Now, what neural search can do that lexical search can't. So here is a real example from Neil's slides, is that if I'm searching for this sentence, what is the capital of the United States? The lexical search doesn't really care about semantics of this question. And so it will find and rank the documents like capital punishment, you know, which is the death penalty that existed in the United States, or that Ohio is one of the 50 states in the United States and its capital is Columbus, but it's actually not answering my question. And the last one is the same. So it's like Nevada is another state and it also has a capital. So you can see quickly that, you know, lexical search finds the words, but it doesn't really find the answer. So it doesn't grok the query. What neural search can do instead is that it can actually capture the relationships between these words, and it understands, okay, you're actually asking about the capital of the United States, and so it knows that it's Washington, D.C., so it knows as in you have a document that answers this question. It also tries to explain what is the capital city. And also the last one, it brings a document where it says, you know, that capital is the building where the United States Congress meets. So all of these are highly related to sort of semantically related to your question. And the way these modern neural search architectures work is that you have what is called a Bi-encoder architecture, where you essentially have a query and a document that is relevant to this query embedded into the same geometric space. And so then some sort of cosine similarity or another similarity is computed, and basically this score is produced by the ranking layer. Okay, another use case, and I will try to show it today as well, is that you can cross the modality. So modality meaning that you are indexing, let's say, images, but you are searching them with text. And so here, a user is searching 2 dogs in the snow. And so these two are close. So this is the image and this is the query, but not close to London at night or cat on a table. And another use case is that you can actually do multilingual search. So if you wanted to do multilingual search with vanilla OpenSearch, Elasticsearch, or Solr, you will have to configure an independent like schema or mapping, and then decide how you do it, whether or not this will be a separate core index, or you will actually blend all documents together in the same core. And both of these approaches have pros and cons. But in neural search, you don't need to do this. So you can compute using a multilingual model a shared embedding for all of the languages. And so if I'm typing my query in some other like language, I'm still able to find it. All right, let's continue. So another important thing to know is that how does neural search sort of compare to lexical search? And there is a really great paper that I highly recommend you to read called BEER, Benchmarking IR, Information Retrieval, which actually presented like 18 data sets, you know, from Twitter, Stack Overflow, Quora, Wikipedia, TREC COVID as well, on different like topics and dimensions. And it also has different tasks. So for instance, one task could be finding tweets that basically reflect a specific news item, or you know, an answer on Quora, and so on and so forth. So all of these different tasks, they pose a specific challenge to the search engine. And so there was like a zero-shot evaluation. So it means that none of these engines have been like changed. So just vanilla models have been plugged in, and basically the comparison was done on NDCG level. And so what happens is that BM25, which is like lexical search, it's very strong baseline. It actually performed well on 10 data sets out of 18. And if you combine this with a cross-encoder architecture where you have like a neural search re-ranker, then it is doing really, really well. But unfortunately, cross-encoder architecture is very slow. And the next in line is a DocT5 architecture, which also performs really well on many data sets, including out of domain. It's a very interesting technique that I will show in a couple of slides. And it's much less computationally intensive. But as you can see, there is still like a lot of like methods that are kind of below the BM25 line. So BM25 is very strong baseline. If there are any questions, let me know. I'm trying to go a little bit fast because I would like to show some demos. But before that, I'll show you the approach that allows you to kind of benefit from neural search without actually implementing it or like slowing down your system and without going away from lexical search. So what you can do is that you can take your input document and you can run it through this model doc2query. So it's also based on transformer architecture here, and it will produce a query, predict a query that might be relevant to this document. So it's kind of like an inverse model. Then what you do is that you take these queries and you might produce, let's say 50 of these, depending on the use case, and you concatenate them with the document and index in your normal lexical search engine, like OpenSearch or Elasticsearch. And so now the user query will bring much more relevant documents than before. And so this is this second model here, which is faster, not as accurate, but still really, really good. So if you don't have a lot of data and clicks, you're like in a startup, let's say, you can try to apply this model and improve your search baseline. Any questions so far?
I have a question. So in this slide is the predicted query indexed as a separate field in another field that's searched upon in the index?
Actually, it's concatenated. So, the document text is concatenated with the predicted query. And so it kind of expands the coverage of your document in a way, lexically. Does that make sense?
Yep, thank you.
So yeah, one other question there. So upon like at inference time, then it's just working off of the inverted index itself in this case.
Exactly. So this will be an inverted index, yes. And you have some magic of neural engine behind the scenes. So it's like on your backend in pre-processing. Yeah. And this is contrary to the approach, which would be a Bi-encoder, right? So like if you were using like a lexical retrieval step, and then you would apply a Bi-encoder re-ranker, then this would always run on inference. So this would kind of a little bit slow down your system. In return, it will give you more relevant docs.
Right, and also I assume it's harder to combine a Bi-encoder with a standard like inverted index based like retrieval system too, because you'd have like two separate architectures that you'd kind of have to maintain and combine results for, right?
Yes, exactly. But there are search engines that beyond OpenSearch or like Elasticsearch that actually combine inverted index with dense retrieval. And so they have like essentially like this geometric space indexed as one index, then inverted index, but all of them coexist in the same architecture, if that makes sense. And then during search, you can actually decide how much weight you put on each of these. But with latest release of Elasticsearch, you also have the neural search capability. You will have to index it as a separate field called dense vector, and then you can like run like probably multiple queries and then try to combine. But then they also have some query parsers which allow you to sort of a little bit combine the results. But I think they will improve on this as well later. This is really great question actually, because essentially if you were to bring in this semantic layer into your existing search engine, then you need to bother about, okay, how do I create a separate database, whether or not it drifts and things like that. So that's why I think it's important to probably consider some kind of query classifications where you can say, okay, or maybe even just the number of tokens beyond which you will trigger a more expensive but more accurate layer. Or you can actually run a query classification and see if this is a question that's asked, right? All right.
So I have one question.
Yes.
So basically, like, how do we use the click metrics in the dense retrieval? Like, is the dense retrieval only applicable if we don't have enough click data?
Exactly. So like you first start with that, or you apply dense retrieval to situations where you clearly see that this is like a question and it's like a fact checking or something like that. So instead of trying to rely on click data only, you can also do neural retrieval. Go ahead. Was that a question?
Yes, yes.
I can barely hear you. Can you? I don't know if you can crank up your microphone.
I can hear you. Hello.
Yes, yes, go ahead. Now I can hear you.
Yeah, I think you answered my question. So that's what I had in mind. Thanks a lot.
Right. Awesome, awesome. All right. So next I was thinking to go and try these different systems, and these are like demos, so to say. One of them I've been actually building with my colleague at Silo AI. So we'll start with this search engine called Muves, and I hope you guys see this. So what it allows us to do is that we've indexed Amazon books, like 1 million books from the Amazon dataset, which is like a publicly available dataset. And we have used a multilingual encoder. So all of the books are in English and all of the titles are in English, right? But I'm able to search this with different languages. So here I'm using Finnish language, miten elää onnellinen elämä, so it means like how to live a happy life. And it's able to, without any machine translation involved, find the books that are quite relevant on this subject. And if I was to type this, let's say in Russian, let's see what happens. So as you can see, I don't know if any of you knows Russian, but here I'm asking about the same thing, and it's able to bring me the books that are reflecting my query. Or I can try a bicycle repair guide in Chinese, and it should also be finding me the manuals that I'm looking for. So these techniques allow you to increase the coverage of queries without really introducing super expensive like processes where you need to actually introduce another index or layer, configure all these languages, and then figure out like what is the input, detect the language, and then route it to the index that represents that language or whatever. So here it's like everything happens in the vector space.
Yeah, I have a question, if I may.
Yes.
What is the best multilingual model that you've found for search?
We've tried only one, I think, and I mean we are kind of fairly satisfied. This is just for the demo, so we picked one from Hugging Face. I think it's like Bird QA. I could try to share later like exact name for it. But of course, it also depends on your situation. For instance, does it cover all the languages that you need? Or if you have some language that is like low resource, then how to kind of fine tune that model. So that's where the whole kind of cooking, begins when you're trying to tune your data. But I'll try to share the name of the model later in the Slack channel.
Okay,
so
cool.
you can follow up. Yeah. This is off the shelf, so we didn't train any models here. And by the way, if you have any queries that you would like to try, just shoot them in the chat or tell me what you want to try. Better if you shoot in the chat, because if it's not English or Russian or Finnish, then I'll have to grab it from the chat. There is like another one here, like this one. So it's able to I guess, capture that. So it's like says dieta here, but it's like nutrition and health, or health and obesity and other like topics here. And so it's not only cross-lingual, but also semantically related.
I put one in the chat for you.
Oh, wow. Is that Polish language, I guess?
Yeah, that's from Gabriel, but try that one as well. Yeah.
What does this mean? It's like preparing something.
Yeah, art of doing pierogi.
Oh, pies, right? Okay, let's see. Baking, is that, do you think it's good?
Yep. Close, yeah.
Okay, awesome. Maybe you were looking for something specific here, but in any case, you can increase the number of results, see if it brings even more. But yeah, if you have any other queries, we can. Oh, there is one. I don't know what it means.
Yeah, just above Gabriel's, I have one. It's books about jazz guitar. Yeah.
All right, let's see. Jazz guitar, sight reading, masterpieces, player book. All right, so maybe this one should be higher or something, but I don't know. But at least it brings it in the top 5.
Oh, that's fine.
There's another one. Is this Chinese from Max? I'm not sure, and I'm not sure what it means. Can you say it?
Yeah, it's Chinese. It's like how to feed Samoyed, like a dog.
Okay, let's see. Oh, wow, what is this? It's probably not what you're looking for.
Maybe there are not books on this subject.
Yeah, it could be because it's only 1 million books. So yeah, it might be we don't have it.
Can you try this, the second query?
Sure. Let me grab it. What do you think?
Not close.
Okay, so we need to improve on this. I guess index more books.
Yeah, maybe there's the limit selection in the index. Yeah.
Yes, exactly. I was demoing some query to my students a couple of weeks ago. Something like this, because in Finland the weather during winter is not that good. And it was actually bringing these books like Why Is It Snowing, which was really interesting finding, which was actually true. It was snowing quite a lot. All right, if you have any other suggestions, we can try them later or now. But next one, I was thinking to move to an example, which is the image similarity search. Okay, and so what it does here is that essentially you can type a query in textual form, and using a model called CLIP, which embeds text and image in the same sort of neural architecture, you are able to find images. And so I was thinking to start with just an example query here. So when I type blue shirt, I'm using, so I'm searching over the image. There is also a multilingual version of this. And so as you can see, it finds these results. Are you happy with these results?
They're pretty much blue shirts, right?
Yes. The only problem I would say is that they are biased towards one gender. And,
yeah, but is it really the word you would use for women? Would you have another search query for that?
Yeah, that's a good question. So like, probably I wouldn't. So
like blouse or something.
Oh yeah, true. You mean like blue, something like this. Yeah, you're right. But I could still do blue shirt because maybe it's called shirt. I don't know. But if I add female, it's able to capture this. So it's kind of like slightly biased there because and this is one kind of well-known property of neural architectures is that it's not able to handle ambiguity well. So like if you type apple and give a hint that this is a company or fruit, then the neural network will do its best and find like a relevant point in the geometrical space. But if you didn't, then it doesn't know what to pick. And so it picks the overrepresented sort of class in a way. I hope that makes sense. If you have any queries you want to try, we can try them here. Yes, and safe mode is advised because these images have been crawled on the web and taken actually from the common crawl. So sometimes some images are not like for work. So that's why safe mode is ticked, but even that is not always like waterproof. Yeah, I guess we can also see like if color is kind of respected here. Oh, okay, something happened. Let's see. My Chrome is trying to, yes, my Chrome doesn't like the results from that search, so I will not show it. Any queries you want to try? Maybe one thing I wanted to show you is that if I'm typing shirt, I'm getting like prints or something here. But if I will type shirts, it changes the result, right? So in a way, it actually reflects my intent. My intent is to maybe see multiple shirts, which probably is not always true. But in this case, the model is very sensitive to my input.
Can you maybe try, this famous example when there's negation, like shirt without stripes or stuff like that? I don't remember, like something that normal search maybe would not understand. Like, yeah.
Yeah, I think
so
it
there are still stripes in there.
Yes, exactly. So it's like because probably it didn't have without in the image description, right? And so it kind of just skipped it.
How does it work with a natural language question? Have you tried those? Well, of course you have, but what does it do?
If you can give me an example, we can try.
Oh, show me electric bicycles.
Let's see. Yeah, it's getting something.
Yeah.
Yeah. So I guess it's just omitting some of these words, but this model, so it was released by OpenAI, and they also have a blog where they show some limitations of the model on the textual part. But in general, it's very like a high-performing model, like across multiple domains, multiple images. So it's quite robust.
What if you type in, but not for children? What if you make it an entire sentence, but not for children or something else?
Yeah, negations, I'm not sure it would handle, but let's see.
Well, that's kind of interesting.
I think it will. Well, here it brings like women's fat tire best folding electric bike. So, but it still brings some images or pictures of kids on bikes. But yeah. If we remove the bot, let's see. Oh, just remove not as well. It will bring more dominating of kids bikes. Was there some question? Is there a model which recognizes, for example, nudist? Yeah, so actually this data set has been released by a company, and they have created a classifier. So basically the way this would work is that you need enough of corpus with like these images so that you can actually like learn to detect them, and then you basically like shoot down all these images. There is another thing that they did is that they computed the vector similarity between text embedding and the image embedding. And if it was below 0.3, they dropped such instances because they thought that their parsing of HTML failed, or maybe that that page was not super consistent. Any other queries you want to try, or do you have any questions on this? Like we can also compare this with pure text search, right? So like now I'm searching just in the captions. At that point, like if I was saying like, but not for children, again, it's lexical search, and so it might not really respect this. We'll have to have some query understanding system here.
Yeah.
Okay, cool. I think we can continue. And the last demo that I wanted to show you is question answering. And so this is a database called Weaviate. It's like entirely different search engine, predominantly for neural search, but also it has inverted index capabilities. And so the use case here is that I can ask questions. And when I ask questions, I usually don't need a full document in return. I just need that specific snippet in the document that is relevant. And so if you remember, there was a shares fall of Tesla at some point, and it was quite significant. And if you didn't know what was happening or why it happened, especially for investors, this might be really interesting. So you might click this. Hope this works. Yeah, so this returns me a snippet where it says that, you know, the shares dipped after Elon Musk asked his followers on Twitter whether or not he can sell 10% of his company stock. And he did, but, you know, the market reacted as it is. And they also have like an interface where you can kind of take a look at what is happening behind the scenes. So it's kind of a GraphQL based search engine. So here you can like manipulate all these parameters and get a different result, or you can get more results. But what's interesting is that if I take this query and if I say, why did Tesla shares fall, right? So I'm not providing the number anymore. What if I don't know the number? It's no longer returning that result. And so this is also like kind of like a known limitation of these dense retrieval systems, that sometimes they will misunderstand the query, or the query is just way too generic for the neural search to find an efficient result. So, but nevertheless, it finds an article, what is up with Tesla's value. And so if you click this one, you know, you might see a happy Elon who decided to sell the stock, and like, but now you have to go and read this article to understand what happened, right? So sometimes you may not have time, but at least it did find the article for you. If you have any other like examples we could try, just shoot in the chat. This is the articles indexed from TechCrunch 2021. So it's not super fresh, but at least it might contain some knowledge there. I think they had a keyboard reviews example also, like what TechCrunch editorial staff is using during creation of their articles. So I mean, sure, might be quite interesting and relevant, but that's not a question at that point.
So this is kind of wide as a use case, right? I mean, it's a nice functionality, and it's very interesting. But what kind of use cases do you have in mind for a system like this?
Yeah, so one is like when you want to check facts. So for instance, if you take a financial search engine and you want to know what is the revenue figure of Apple in Q3 or something like that, right? You don't want to see numerous like articles about Apple or like documents or their financial reports. You just want to get that number. And so basically question answering could be one use case for that. Another is when users have exhausted the keyword search and they still didn't find everything that or maybe they're afraid that they're missing something. You can run an explorative search using neural search. And so kind of try to figure out if there is a semantic relatedness between what they're asking and what you have. So that's another like use case. But for neural search, there is a lot more use cases beyond simple search. For instance, in the recommendation engines, or if you need to find those nearest neighbors in your algorithm, right? Like in testing or in developing, then you will also use neural search.
How does the engine define a fact? I mean, if you were about to generate text, for instance, you can get lots of really well-written text, but what it usually gets wrong are the facts.
Yes.
And,
yes.
and how would you guarantee that the facts are what actually are
Yeah.
tracked?
Yeah. I would say that fact checking is very complicated topic. There is some research on this topic, but in general, I don't think it's kind of nearly solved. So it's far from solved. But I think what neural search is kind of doing is just it pays attention to the context, right? So like here, I'm asking like, why did Peloton shares fall? And I think they fell at some point. It's kind of like, it doesn't care that I kind of changed I didn't change the question, I just changed the company here, but it's able to kind of semantically map to the similar template and like, okay, you know, share price falls this much after something happened. So this one is not a fact, right? But it's kind of like still giving me some information that enriches my understanding of what's going on. So it gives me numbers, for instance, right? So I wouldn't, yeah, maybe I was too bold in saying facts, but it's more like a context.
Yeah, but it's a really important question, yeah.
Yes, absolutely, I agree. Like, I think facts is like important when you either checking something or you are writing text, as you said, right? So, so I would not maybe fully rely on such systems for facts. Is there, there is like,
what happens if you ask it something about the future or something? Yeah.
There is, so the thing is that this is 2021, so it will not, probably will not have it, but let's see. So this is a question from Gabriel. The biggest infrastructure investment opportunities, predicting the next wave of Southeast Asia tech giants, the big question on every startup's mind for 2021. So you could say it's talking about some future there, right? Now the question is, what were you looking for? Like if you looked in specific domain, or like maybe you could have another filter there. And that's another thing, by the way, that these search engines also allow you to apply filters. Although this is also like computationally intensive process, because sometimes it reduces to finding exact neighbors and not using more efficient approximate nearest search, but still like Weaviate and other databases support filters. There is another query. I'm not sure if this was from Emre, I guess related to books, or did you want to try it here? Yeah, the answer is 42, but I don't think this will get it. But if we go to Muves, let's see. Again, this is live. I don't know what's going to happen. Okay, so I'm developing 21st century AI. So because you already know that 42 is the answer, you might also as well educate yourself on something else. Okay, any other questions, or like
what is the best way to address performance when you do dense vector search?
Yeah, that's a really great question. So there are multiple ways that you should kind of, and maybe at this point I should go back to the slides. This slide is just showing you that there are a number of algorithms that are being tried out and developed by major companies, you know, out there at scale. So the problem is that you will never get exactly precise in neural search, because it's simply impossible to enumerate all neighbors, right? So it would be order n, which is too slow for large collections. And so they developed a number of like approximate nearest neighbor algorithms, you know, that bring you similar performance. Maybe you have a drop of 5–10%, but you will still be down to like milliseconds. And another way to optimize the search is to quantize your model. So like instead of using the fully blown dense retrieval model, you could actually build like a quantized representation of it. So one way is to teach a student model using your teacher model. So teacher model is a bigger one, and the student one is learning. But there are other approaches how you could do it. but this is very, very important question, actually, I have to say. We've also worked as a team on one ANN algorithm, which we called BuddyPQ, and we were able to improve over FIS on 10 million documents. So we were not able to improve it on 1 billion, but for 10 million, and maybe if roughly you have that many items, it was outperforming the Facebook's open source algorithm for a specific data set. Any other question or questions?
Facebook's the one from that's the Annoy one, right?
Facebook has FIS, and Annoy is from Spotify.
Yeah. Okay. Sorry.
Yeah. Yeah. I think by now FIS is probably the most popular, but Annoy, I believe they still use Annoy in Spotify, but Annoy also has certain things like doesn't always work stably on all data sets. So FIS offers you a number of parameters that allow you to kind of tune your model to scale to a specific like number of documents or items. Okay, and as you can see, by the way, on this x-axis, you know, the recall or like how much of relevant items you are finding, it will never be like 1 because it's like approximate, because we are not enumerating all of them, but we are like approaching like decent number, which could be useful in practical setting. Okay.
Hey Dmitry, I have a question.
Sure.
So yeah, it's very cool to like the vector-based search and then the vector database. I wonder, so given the current infrastructure, like for example, Solr, right? Can we just index this embedding into the index, for example, for every product? And then so I wonder, like, do we really need like the vector database for this to work, or can we just use some like offline ANN index first? For example, put all the queries related to a product into the index.
Yeah, so actually in Solr specifically, the recent release of Lucene, which introduces HNSW algorithm. This is like a ANN algorithm for vector search. It has made its way to Solr, and so you just need to upgrade your Solr to that latest version, and so you will have a dense vector type, and then you will be able to run a neural search. There is a blog post actually that I could try to look it up, and it actually introduces it like as a tutorial for you.
Sure, I know it's Lucene 9 that has like the ANN algorithm, the HNSW there. But is it already out? Like, is it?
Yes. Yeah.
Oh, okay.
Yeah, it has been already integrated.
Okay, how do you weigh the pros and cons between using this native Lucene implementation of a vector-based search versus, for example, our own implementation of this pipeline that generates the ANN without depending on the search engine?
So actually, specifically on the algorithms, the HNSW, which is hierarchical navigable small world graph algorithm, one of the most popular ones used in many search engines, like even on this screen. The problem is that in Lucene, or maybe it's not a problem, but maybe a little bit like a limitation to keep in mind, is that they implemented only the one layer in that graph. So it's like multiple layers in the full representation of your data, but they only implemented one. And there is no technical limitation for them to implement all of them, but like right now they decided to only launch like one layer. So maybe for, I don't know if it's a limitation of number of documents in the index. It's something you will need to check. But looks like, at least in that tutorial that I will try to look up, they show that the neural search outperforms the lexical search in terms of QPS. And again, this is something you need to check out. And the second part of the question I didn't quite get. Can you repeat that, please?
Oh, yeah, I was just asking like how do you weigh the pros and cons? Basically, I think you answered this because the question is like, do we need to use Lucene native implementation for vector-based search, or should we implement our own data pipeline to like run this ANN algorithm in our, yeah.
Yeah. I would approach it from the point of view like of creating ground truth. So you have queries and you have ground truth of top 10 results, for instance, right? And now you can actually cross-check all of these engines and see which one is better. If you need like software to do this, like there is ANN benchmarks website, which compares all different algorithms. So you could like take some code from there or implement your own. And so you would basically compare them on, oops, did I miss that slide? Yeah, you would compare them on recall and QPS, right? So what you care is that increasing QPS without like losing much of recall, because in general, you could make just a random search and it would be super fast, but recall will be down to 0. Or extreme case, you enumerate all of them in KNN search, which is like exact search, but your QPS will be very, very small. So between these two extremes, you can actually benchmark all of your approaches and plot them and see how they perform, but you will need to have a ground truth. Hopefully, either you have it already or you can build it based on like user interactions or using your quality assurance team.
Yeah, got it. Yeah, thanks.
Yeah, you're welcome. That's a really great question, actually.
So, Dmitry, I have another question.
Yes.
Like, I would like to see, like, what is the recommended architecture for combining both BM25 plus dense retrieval, because the cross encoders is kind of expensive.
Yeah.
So,
yes,
what do you suggest?
So according to this research in the Beer paper, DocT5 is the best. So basically, instead of using the neural re-ranker as the post step after your lexical retrieval, you just do some magic behind the scenes. You run your neural network and you index more data in your documents. So that was kind of a surprisingly maybe simple and kind of straightforward approach, but it works really well in out-of-domain data sets. So it performs well on the data set that it was trained for, and then 10 more data sets that are out of domain, it still performs better than BM25. So it gives you an improvement.
Got it. And also, I would like to understand, like, in your experience, did you see a scenario where you already have a production system running, which is on BM25? And how did you integrate dense retrieval into that? Because we cannot stop what the work we are doing and directly go to a new architecture all of a sudden. And we don't know what are the business impacts, because sometimes the dense retrieval might look pretty good on paper, but it may not work as expected in production system. Like, how do we transform slowly a BM25?
Yeah, this is an excellent question. And so actually we are now working on one system. It's kind of like a demo system on top of production system. And we are going to experiment in kind of blending the boundaries between neural search and the lexical search. And if you look at a framework called Gina AI, they have a couple of demos where they assign different weights to kind of exact search versus like inexact search, and you can see results. For instance, in the case of image and text retrieval, you can say pay more attention to image features and less to text, or vice versa, right? Now, something similar, not similar, but a technique exists to blend lexical search and neural retrieval search, and it's called reciprocal rank fusion. So you can take a look at this. It has been actually proven that it outperforms like all other interleaving methods. And I think one paper was from Google, one from Microsoft. So it's something that I've learned recently. Hope this helps.
Yes, thanks a lot, Dmitry.
Yep, you're welcome. All right. Is there any other question? Happy to answer Or do you guys think that neural search is something you could try, or do you think it's too edgy?
I would actually like to try it. I have actually a question, like, I have one hypothesis or maybe one plan in my head, and I would like to maybe help me to validate that one, right? I mean, many of us like work in e-commerce search or marketplace search, when there's like specific requirements for features like facets, and the filters and aggregations, like, all the drill, the slice and dice functionality. And then the question is like, of course, like it doesn't work well with approximate nearest neighbor, as they, just keep top K. So you wouldn't even know if you could handle like larger K, you don't know when to stop, right? At which point. So I'm guessing like, would it make sense to design a test when, for example, we have LTR, and one of the features is a cosine similarity of a dense vector, when we just, calculate that. So we have a off-the-shelf, let's say, transformer like BERT. We encode the document with that and as a dense vector field. Plus, we do the same for a query. And then we have this external feature, right, for a top K, which we then try to learn and make any sense out of it. And would that make would it be a good experiment, to try that to maybe to add for a context, because my impression is that might enrich, like, that this feature that also encodes the context, right? And maybe that would help in some queries,
Yes, absolutely. Yeah, I think this is maybe kind of a safe bet to try out as a feature. Another thing is that at least I would try to look at queries, for instance, when you say like laptops or laptops for kids, then you might not have that category labeled right in your data, but if you're able to capture like some semantic like similarity between laptops for kids with laptops of some specific category, then similarity search might work better. But in that case, you will have to have some kind of query understanding system that is able to delineate, these queries and say, okay, this one goes to lexical search or learning to rank, and the other one goes to dense retrieval. But yeah, you might also have multiple stages of ranking as well. So that's something that is happening today as well. But good point on the feature.
Thanks.
Yeah, you're welcome. Is there any other last minute question? I guess we're close to the top of the hour, but this was quite fun session. I still have a lot of slides, but I will not bore you with them. You can actually find an online presentation I will share with you, where I also compare these neural databases and also speak a bit about neural search frameworks.
I have another question. In terms of metric, so in terms of the K-Annan metric and the metric that is used there, if there is some studies related to that, and if there's some particular inference in terms of the manifold that the vectors spawn.
Yeah, so I can actually recommend two things. One is a beer paper. Because they actually allude to things like if you use cosine similarity, then it will favor shorter documents over longer documents in the case of TIE. If you use dot product, then it's the opposite. And it might actually influence the user experience in your case, right? Because you might have a mix of different document lengths. And so different documents might sort of answer to the query also differently. So that's something to keep in mind. And the second thing is called deep metric learning. So it's a process of actually identifying the metric that is best representative of what you are trying to do in your data set. Because your data set is like real things that you understand, but the model doesn't. And so the model needs to learn a representation of your objects in the multidimensional space that makes real sense, right? It's like in terms of geometry. So that, or maybe even this one. So that all these objects, are semantically related, they are also closed in space. And that's, so take a look at deep metric learning. There are some tools as well that you can kind of try out, but also papers. Hope that answers your question.
Yeah, thanks a lot. And will you share your presentation?
Yes, yes, I'll share the slides. Absolutely.
Yeah. And thanks a lot. This excellent content. Thanks.
You're welcome. Thank you for the question. And I guess if you want to follow what I'm doing or like chime in, listen to the podcast, feel free to follow or subscribe.
Thank you so
Dmitry.
much, Dmitry.
Thank you.
All right.
Thank you.
Thank you very much.
Okay, bye everybody.